One of these feels real, the other, not so much. Why does Mario feel fun to control while others just feel stiff? Today, we're going to uncover the hidden secret behind great movement in games and build both types of movement side by side right here in Scratch. You'll see how a little bit of physics makes a huge difference. All right, let's start building our basic movement system. Now, we want our sprite to always start in the same place when we run the game. Next, we're going to wrap our movement logic in a forever loop. Let's start with moving right. When the D key is pressed, let's point the sprite in the direction it's facing, which is 90 degrees for right. Then, still inside that block, add change x by 5. Duplicate that if block, but this time change the key to A, the direction to -90, and the change x to -5. And just like that, we've got simple, responsive left and right movement. It works, but it doesn't feel great. It's snappy, robotic, and there's no sense of weight or momentum. But that's exactly the point. We're starting here so we can appreciate the upgrade we'll be building next. All right, let's move on to the second movement style, this time with acceleration and friction. We're going to create new variables, dx. This stands for horizontal velocity, how fast the sprite is currently moving left or right. Acceleration. This controls how quickly the sprite speeds up when we press a key. Friction. This helps the sprite slow down gradually when we let go of the keys. Max speed. This is the top speed the sprite is allowed to move. Without it, the sprite would keep getting faster forever. So once we set our variables, we need to initialize them. Set your dx to 0. Initially, the velocity should be at 0. Next, set acceleration to 1, friction to 0.9, and our max speed to 5. Also, set the initial position. Drag a forever block, and inside it, change x by dx. What we want to do, essentially, is to change our x position based on the dx value. So let's work on setting up our dx value. First, get an if-else block. Check if the D key is pressed. If it is pressed, we want to point in direction 90, which is the right direction, and then change dx by acceleration. In the else part, we check if the A key is pressed. If it is, then we want to point in direction -90 and change dx by a negative value of acceleration. In other words, we multiply acceleration by -1. Now, if we test our game, you'll see that the player over-accelerates while holding the keys. Before we move on to stopping the player, let's add conditions to cap the speed. If dx is greater than max speed, then set dx to max speed. Do the same for the opposite direction. If dx is less than negative max speed, then set dx to negative max speed. Now, if we test this out, you'll notice that the player now has a maximum speed and can also change direction much quicker than before. But there's still one problem. The player doesn't stop. Let's fix that. We'll check for two conditions. First, if dx is greater than 0, meaning we're moving to the right, we want to change dx by friction, by multiplying friction by -1. This causes the player to lose momentum and slow down. However, we also need to make sure that we don't overshoot 0. So if dx becomes less than 0, we set dx to 0 to stop the player. Then, this time we check to the opposite direction. If dx is less than 0, meaning we're moving left, we change dx by friction, this time to slow down from the left. And again, if dx becomes greater than 0, we set dx to 0 to stop the player from moving in the other direction. Now, if we test our player, you'll see that they now have momentum and much smoother movement than before.